And Veda is not joining. She has some examination tomorrow.
Sure, sure.
Rest of all joined.
Yes, okay, no problem. Thank you, Vinay. So 2 to the power of 4 is equal to 4 square. Therefore, 2 can be written as 4 square to the power of 1 by 4. Therefore, you can clearly see that 2 is nothing but 4 to the power of 2 by 4. If you can see, 2 by 4 basically is nothing but 1 by 2. Therefore, you know that 2 is nothing but equal to 4 to the power of 1 by 2. Correct? So here, what we are trying to learn here, if you can clearly see, is, we are leading to something very simple and easy to understand. If we have any number, something like a to the power of p is equal to b to the power of q, we can write a to be nothing but equal to b to the power of q by p. We can write a is equal to b to the power of q by p. So if we have, if a power p is equal to b power q, where p and q are integers, whether they are positive integers or negative integers, doesn't matter. If p and q are integers, a is equal to b to the power of q by p, where here p comma q belong to integers. P comma q belong to integers. If a power p is equal to b power q, then a can be written as b to the power of q by p. Now, that's what I want everyone to understand. So here, the power is a rational exponent. You can see q by p or p by q, wherein whether it is in the form of q by p or p by q, we know here in the denominator this p cannot be equal to 0, right? As long as that q by p or p by q, as long as the exponent is rational, it fits into the bill of rational, right? So this is how we look at the rational exponents. A is equal to b to the power of q by p, where q by p is a rational number. You can see here b is equal to q by p. So whenever we have something like, you see, x to the power of 3 is equal to, say, let's assume 3 to the power of 2. So someone says x to the power of 3 is equal to 3 to the power of 2, then we can simply say that x is equal to 3 to the power of 2 by 3. Okay, I need you to understand this. If anyone doesn't understand what we are doing here, this will imply that x is equal to 3 to the power of 2 by 3. Right? If you're fine with it, just say yes in the chat box. Akshat says no. Why no? Why, Akshat? What's the problem? Akshat, you can use mic. Where are you confused? What happened to your mic, Akshat? Okay, so are you okay with this, Akshat? Are you okay with this piece? Are you okay with this piece? If a power p is equal to b power q, are you okay with a is equal to b to the power of q by p? Are you okay with that point? Then what's the problem with this? This is a similar example. If x power 3 is equal to 3 power 2, I've just given an example. I'm just doing an example here, nothing else. I'm giving an example of this. X to the power of 3 is equal to 3 to the power of 2. Then x is equal to 3 to the power of 2 by 3, right? This 3, if it goes on that side, it will be in the power by 3, right? If you're not able to understand, let me do it the step once again. If you have x to the power of 3 is equal to 3 to the power of 2, right? I want to remove this 3 from this side. What will you do? You will raise this also to the power of 1 by 3, this also to the power of 1 by 3. Right? By doing that, this x to the power of 3 whole to the power of 1 by 3 will be x, because 3 and 1 by 3 gets cancelled. That should be equal to 3 to the power of 2 by 3. So that's exactly what we have written here. So what's the problem? Oh, yes, understood. Wonderful. Wonderful. Okay, let's take another example now. Say, let's assume if someone gives you if someone gives you x to the power of 3 is equal to 3 to the power of minus 2. So x to the power of 3 is equal to 3 to the power of minus 2. So does it make any difference? Even this will not make a difference. Once again, this will become x is equal to 3 to the power of minus 2 by 3. So that by 3 will still remain same. But if we want to write this as a value, x is equal to 3 to the power of minus 2 by 3, we know a to the power of minus m is nothing but 1 by, tell me what is a to the power of minus m? A to the power of minus m is equal to 1 by?
1 by a to the power m.
Wonderful. It will be 1 by a to the power of m. A to the power of minus m is 1 by a to the power of m. Therefore, x is equal to here. If x cube is equal to 3 power minus 2, x is equal to this 3 will come this side, 1 by 3 in the power exponent. I hope everyone is able to follow this step. The second step. Right from here.
Can you explain again?
Which one, Arya?
Sir, the second step.
Okay, let me do it slowly then. Let me do this slowly. 1 second. Okay, now we are getting into some another new example here. First, let me draw a line to separate the old example. This is a new example that we are discussing now. If x cube is equal to 3 power minus 2. So here this is if, that means it's given to you. If x power 3 is equal to 3 power minus 2. Right? How do you get value of x? So I'm saying once again, I'll raise this to the power of 1 by 3. I'll raise this to the power of 1 by 3. So it doesn't matter now. So now x to the power of 3 whole to the power of 1 by 3. What will happen to this on the left hand side? Arya, x to the power of 3 whole to the power.
3 and 3 will get cancelled.
Correct. Therefore, you will get x on the left hand side.
Yes.
What will you get on the right hand side?
Sir, you will get 3 to the power of 2 by 3. Minus 2 by 3. Sorry.
Minus 2 by 3. Wonderful. So what I am saying is you got x is equal to 3 to the power of minus 2 by 3. So where did we start? The question was if x cube is equal to 3 to the power of minus 2. Thus, that will lead me to saying that x is equal to 3 to the power of minus 2 by 3. But I can just write it as 3 to the power of minus 2 by 3. But I can also write this as x is equal to 1 by 3 to the power of minus 2 by 3 can be written as 3 to the power of 2 by 3. Is that okay with everyone?
Yes, sir.
Minus in the numerator, if it goes down, it will be positive, right? That comes from this particular logic. A to the power of m, a to the power of minus m is equal to 1 by a to the power of m. Is that okay?
Sir?
Yes, sir.
Yeah, Ronak.
Sir, but 3 will get minus 3 now if we get down.
No. Just minus, it's minus of 2 by 3. 2 by 3 is a value. Just imagine 2 by 3 is some constant. It's like x is equal to 3 to the power of minus k. If you have x is equal to 3 to the power of minus k, x can be written as 1 by 3 power k. K is a number there. Numerator and denominator together, that is becoming a value. Your 2 by 3 will not become 2 by minus 3. 2 by 3 is a value. 2 and 3 are not separated there. It's basically 2 by 3 is a value. It's like any other number. But it's a rational number instead of a natural number or an integer there.
Yes, sir.
Got you, Ronak?
Yes, sir.
Good. So don't worry, we'll solve a few examples, then you'll understand. So we already discussed negative rational. Now, let's understand what is called a radical and what is called a radicand. So basically, whenever we have something like okay, so whenever we have, say, let's assume, I'm looking at a situation now. Just observe. So whenever we have, say, something like x cube is equal to, say, 5. X cube is equal to 5. We know x can be written as 5 to the power of 1 by 3. Now the same thing can be written as x is equal to cube root of, the way we call it as cube root of 5. We say cube root of 5 or third root of 5. So we can say third root of 5 or cube root of 5. That's how we say it. X to the power of 3 is equal to 5. Therefore, x is equal to 5 to the power of 1 by 3. I hope everyone understands the second step, right? This is if x cube is equal to 5, that will imply that x is equal to 5 to the power of 1 by 3. That is, x is nothing but equal to cube root of 5. So in this, if you can see this particular piece, now this is of the form q to the power of y. You can see q root of y. Another way of saying is q root of 5. Qth. So qth root of y. Now here, the value under this root y, that is called radicand. So in this example, tell me what is the radicand in this example? Anyone? Radicand. So your radicand is nothing but 5. Wonderful. So now here, what is the radical here?
Q.
Very good. Very good. Radical is nothing but this q. This one. Very good. So here, what is the radical? Tell me.
3.
Very good. Now, radical sign is nothing but whatever this sign we are talking is, this sign is a radical sign, right? So that's how we look at these numbers. Okay, let's take more examples. This nothing is all definitions. I'm not interested in definitions. Let's understand the concept. So a radical is an indicated root of a number of expression. That's a very simple definition. The radicand is a number or expression under radical sign. So here, what is the radical? Thus 80 is the radicand of. So in this cube root of 80 or fourth root of 80, what is your radicand? What is your radicand in both of them?
80.
80 is the radicand. Correct? Is everyone okay with that?
Yes, sir.
Very good. So now mixed radicals. From the definition, can anyone understand from the definition and tell me what is a mixed radical? Anyone? You can see the definition there. Can you see the mixed radical definition? Tell me what is a, one second. One second.
Sir.
1 second, beta. 1 second. My system is giving me a trouble. I'm pitching up. Just give me a second, guys. Yeah, go ahead. 1 second. All of you? Perfect. Yeah. Yeah, tell me, what is a mixed radical? Yes, Naisha.
Yeah, so suppose it's like, can I give an example with numbers?
Yeah. Go ahead.
Yeah, so suppose it's 3 and root 5,
Very good.
then
Very good.
it'll be root 15.
3 and root 5. How will it be root 15? So 3 and root 5. So you're saying 3 into root 5.
Yeah.
So 3 into root 5 is 3 root 5. The way we write it as, it's 3 root 5. So it is not cube to root of 5. It's 3 root 5. Correct?
Yeah.
So how did you say it is 15, root 15? What did you say?
Because it says the product of a rational and an irrational factor.
So yeah, so product of a rational, so 3 into root 5. So do you think 3 into root 5 is root 15?
I'm guessing that's what it means.
No. Can anyone tell me what is 3 into root 5? What is the value of 3 into root 5? Can anyone simplify what is 3 into root 5? See, that's what we have learned in the previous class, 3 into root 5. If you want to simplify this, how will you simplify? So 3 into root 5. Basically, it's a mixed radical. 3 root 5 is a mixed radical. But how do you simplify this? If I were to simplify this, I can write 3 as square root of 3 square into root 5. Can I write that? Naisha, I'm writing 3 as square root of 3 square.
Yeah, you can.
Why we can write like that? Tell me.
Because 3 square, the square root of 3 square would be 3.
Wonderful. Square root of 3 square will be 3. Now the problem is your square root of 3 square into root 5. Now you can multiply. Because why you can multiply? Because it's in the form of 3 to the power of 2 whole to the power of 1 by 2 into 5 to the power of 1 by 2. If your powers are same, it's of the form into b power m, a power m into b power m. What is that equal to? Tell me.
AB power.
It's
AB
AB
power
to the power of m. Wonderful. It will be AB to the power of m. A power m into B power m will be AB to the power of m. We learned this in the previous class in session 2. If the powers are same, the values inside will multiply. Now it will be, you can write it as 3 square, 9 into 5. It is 45 to the power of 1 by 2. Now it is 45 to the power of 1 by 2. You can write it as basically square root of 45. So 3 into root 5 will simplify to become root of 45. So we need not do so many steps. The other way of solving the same thing is 3 root 5. 3 root 5 is basically nothing but when 3 goes inside the square, it will become 3 square. It will become 3 square into 5. That's how the math goes. When 3 goes inside the square root, when it gets multiplied, if you want to multiply 3 into root 5, 3 when it gets inside the square root, it will become 3 square into 5. That's how it will become square root of 3 square is 9, 9 into 5 is 45. Do you understand this? Does everyone understand this simplification? If yes, mention yes in the chat box quickly. Very important, very important. Okay, let me check how many of you understood this. Tell me let me check how many of you understood this mixed radical properly. So 3 into root 5 is called a mixed radical. So let me give another mixed radical example. I want simplification also. Tell me, okay, 5 into cube root of 7. Tell me the value of 5 into cube root of 7. 5 into cube root of 7. Tell me the value in a single radical form, in the simplest form. In the simplest form, 5 into cube root of 7. I want everyone to write an answer in the chat box so that I get to know everyone understood or not understood. Tell me the answer in the chat box. Tell me the answer, Ishant. Very good. Very good, Ronak. Very good. Yes, yes, yes. Sure, Arya, I'll explain. Don't worry. Don't worry. Okay, let me take another example. Now here we are doing 5 multiplied with cube root of 7. 5 I need to multiply with cube root of 7. Now basically if you can see Arya, 5 and cube root of 7, they have different powers. Basically it is 5 to the power of 1. This is basically 5 to the power of 1 multiplied with 7 to the power of 1 by 3. Right? Now basically I cannot multiply these numbers directly. Either I have to make the base same or the powers same. How can I do that? I can write 5 to the power of 1 as 5 to the power of 3 whole to the power of 1 by 3. I can write 5 to the power of 1 as 5 to the power of 3 whole to the power of 1 by 3 multiplied by 7 to the power of 1 by 3. Now if you can see, the powers are same. Now you can see the powers are same. If you can see the power, this 1 by 3 and this 1 by 3 is same. Now because 1 by 3 is same, it's of the form, if your powers are same, a power m into b power m is ab to the power of m. We learned this in the previous class. It's like this. For an easier example to understand, if we have 2 to the power of 3 into 3 to the power of 3, we can write it as 2 into 3 whole to the power of 3. Because the powers are same, therefore inside they will be multiplied. 2 into 3 whole to the power of 3. A power m into b power m is ab whole to the power of m. Did we learn this in the previous class? Yes. So basically 5 power 3 whole to the power of 1 by 3 into 7 power 1 by 3. So basically I can multiply inside. That is 5 cube into 7, 5 cube into 7 whole to the power of 1 by 3. Whole to the power of 1 by 3. Now what is 5 cube? 5 cube is 125. 125 into 7 is 875. Basically it's 875 to the power of 1 by 3. 875 to the power of 1 by 3 can be written as cube root of 875. Is everyone okay? Is everyone okay? Please mention yes in the chat box quickly. Arjun, you're not responding. Alex, you're not responding. Kirtana, all okay? Very good. Very good. So we'll come to these definitions later. First, let's understand some fundamentals. Okay, so let's do some simplification. Then we will get on and go to the definitions. Otherwise, you'll find definitions difficult to understand. Let's do math first. Let's get comfortable with numbers first. Okay, square root of 25 is 5. That is, square root of 25 is equal to what now? Can anyone tell me what is square root of 25? Square root of 25, how will you do it? Square root of 25. That's nothing but 25 can be written as 5 square. 5 square. So basically it is 5 square to the power of 1 by 2. So 5 square to the power of 1 by 2. Therefore you know a power m whole power n. A power m whole power n. You should start seeing the formula easily. It's a power mn. Therefore we are multiplying 5 to the power of 2 into 1 by 2. Those exponents 2 and 2 gets cancelled. That's the reason it is 5. So square root of 25 is 5, right? Similarly, cube root of 27. What is cube root of 27? You know 27 can be written as cube root of 27 can be written as 3 to the power of 3. Therefore, basically it is 3 to the power of 3 whole to the power of 1 by 3. This 3 gets cancelled. Answer is 3. So quickly tell me what is 6th root of 64? 6th root of 64 will be 2 because 6th root of 64, your 64 can be written as...
So 2 to the power of 6 is equal to 64, so indirectly 6th root of 64 becomes...
Correct. Therefore it is 2. Correct. So that's the logic that you need to understand there. Good. So... Okay, so here there is a very simple concept here, order of the surd. In nth root of a, n is called the order of the surd or a radical. Okay, so we'll get into the difference between a surd and a radical. For the moment, let's understand when we have something of the form nth root of a, we call it as a radical also. But here nth root of a, if I take it, whenever we have something like this, nth root of a, say for example, third root of 4, or you have fourth root of 5, you have fifth root of say 100, right? In all these cases, this 3 or this 4, this 5 is called the order of the radical. We'll come to the third later. First, let's understand a radical in detail. So this 3 or 4 or 5, this is called the order. Say for example, we have seventh root of say 56. Now what is the order of seventh root of 56? What is the order of the radical seventh root of 56? It's called 7. Wonderful. Wonderful. Now let's get into some fundamental laws of radical. Now, nth root of a whole root of n. So there is nothing, just I need you to learn one simple fundamental. All the formulae that were applicable, the formulas that were applicable for a power m whole power n, we learned this formula a power mn, right? This m and n, there it was natural numbers that we learned, right? So that logic holds good for even the radicals. For example, if we have here nth root of a, all those formulas are applicable. You have nth root of a whole to the power of n. Nth root of a whole to the power of n, basically it is a to the power of 1 by n. Nth root of a is nothing but a power 1 by n whole to the power of n. So that formula, this formula is applicable here also. Basically, it will give you a to the power of 1 by n multiplied with n. Therefore, n gets cancelled. Therefore, a to the power of 1. So that's the reason you got nth root of a whole to the power of n will give you a. Now coming to this formula, this is also not a rocket science. Nth root of a multiplied with nth root of b. Now what is nth root of a? Nth root of a is nothing but a to the power of 1 by n. A to the power of 1 by n multiplied with b to the power of 1 by n. So basically, if you can see, the powers are same. Powers are same. What is the formula that will come to your mind? The only formula that will come to your mind is a power m into b power m. If the powers are same, I can multiply inside. It is ab to the power of m. Does that hold good? That's what we learned, right? A power m into b power m is ab whole to the power of m. Therefore, same logic holds good here. Because the power is 1 by n, it's basically ab whole to the power of 1 by n. That's the reason it will be nth root of ab. Nth root of ab. So nth root of a into nth root of b will always be equal to nth root of ab. I hope I'm making sense to everyone. Correct? Now same logic holds good here. If you have, yeah, so nth root of a divided by nth root of b. Basically, it's like a power m by b power m. We learned if the powers are same, if they are divided, the values can be divided normally. It will be a by b whole to the power of m. This is also another formula that we learned in our previous class. Like this, we have learned this formula also. All these formulas are just putting a star mark. Just take a note of all this. All these formulae. We have done these formulae in the previous class. All these formulae, we did this. I actually showed you the proofs also, if you remember. I just did not give you the formulae. We have proven them. We are solving, Ronak, wait. First, let's get the concepts right. Then we'll go to the problems. Therefore, nth root of a by nth root of b will be nothing but nth root of a by b. Does anyone have any problem with any of these rules? Does anyone have, if all okay, say okay. Okay. Now, this is little complicated. So once again, if there is something complicated, don't worry at all. Let's understand. Now, whenever you find something complex like this, don't fear. Don't fear. I'll tell you why you should not fear. This looks very complicated, but it's not. Basically, he's saying mth root of nth root of a. Now, basically, what does that mean? Basically, first we'll go from inside. Mth root of a. That is nothing but equal to mth root of. What is nth root of a? Nth root of a can be written as a to the power of 1 by n. Nth root of a can be written as mth root of 1. So now, what can I do in the next step? The next step will be mth root of a power 1 by n. That means nothing but a power 1 by n whole to the power of. What do you mean by mth root of apple? Just imagine this as some apple. I'll just change this color. I'm saying this is nothing but some apple. Now what is nth root of apple? Apple to the power of 1 by m. Apple to the power of 1 by m. Correct? Mth root of apple will be a to apple to the power of 1 by m. But what is apple there? Apple is a power 1 by n. A power 1 by n whole to the power of 1 by m. Therefore, basically this is nothing but a to the power of 1 by n multiplied with 1 by m. Why we are multiplying? Once again, this is of the form a power m into, a power m, one second, just hold. It's like a power m whole to the power of n. What is a power m whole to the power of n? A power capital M multiplied a power capital M to the power of n. What will that be equal to? That is nothing but equal to a to the power of m into n. That's what we learned, if you remember. A power m whole power n. A power m whole power n is a power m into n. Did we do this? Yes, we did all this. We have proven all this. Yes, Akshat. Very good. I'm just trying to make your life comfortable. So generally when students see such big radicals, they think that is a rocket science. It's not rocket science. So basically a power 1 by n whole power 1 by m will be a power 1 by n into 1 by m. So you can see this will be nothing but this, that will be nothing but equal to this. Just if you look at what do you mean by a power 1 by n into 1 by m. If I simplify this further, let me write it this side. The same thing I'm writing it here. Just observe this now. A power 1 by n into m. So I can write it as a power 1 by nm. Correct? What do you mean by nm or mn? You can write anything, 1 by mn. So what is 1 by mn? I can write this as mnth root of a. That's what exactly is written here. Mnth root of a. Very good, Akshat. Very good. Very good. Very good. So here, what it is trying to teach you is you can play around. You can actually play around them. Basically, it's nth root of AP. He's saying nth root of, he has introduced m, but he divided here with m. You can see that m gets cancelled. So if you observe this piece now for a moment. Now, mnth root of a power p power m. So if I simplify this, it's nothing but a power pm whole to the power of, this mn will become 1 by mn. That mn will become 1 by mn. Basically now pm into 1 by mn will be this m, and this m gets cancelled. This will be nothing but what? A power p by n. A power p by n. Now a power p by n is nothing but this. You can see. What do you mean by a power p by n? It is nothing but nth root of a power p. It's nothing but nth root of a power p. So it's just playing around with the radicals. So as whoever has written this, if he is playing with the radicals, I'm sure all of you can play with the radicals. My question to all of you, now can you play with the radicals like this? If yes, mention yes in the chat box. Okay. I don't see Ishan responding. I don't see Arjun responding. Alex, Kirtana, I want to see you responding. Good. Ah, very